Today we're going to be graphing cubed roots, okay? We're going to start off by just graphing the parent function just like we start off every graphing unit, okay? So our parent function is just y equals the cubed root of x. So you can write it again over here. It's the same thing as x to the 1/3 power as well, okay? So cubed root of x is the same thing as x to the 1/3. Are we all good on that? Yes? No? Maybe so? Okay. So it wants us to use a T-chart to graph the following. But before we do that, let's have a real quick discussion. Cubed roots, are they always positive? Is it okay to have a negative in a cubed root? No. Yeah. Yes. Why? Because the index is odd, and we can have negatives underneath of those roots if it is odd, okay? So, before, when we had square roots, the four numbers that we set our radicand equal to were what? 0, 1, 4, and 9, okay? So if I went ahead and found the four perfect squares that are positive of cubed roots, or not perfect squares, but perfect cubes, okay, they would be this. 0 to the third, 1 to the third, 2 to the third, and 3 to the third. So let's just go ahead and do that. So type these into your calculator. What's 0 caret 3, or 0 to the third? 0. What's 1 to the third? 1. What's 2 to the third? 8. And what's 3 to the third? What? 27. Okay? So just with this parent function, those are going to be my first four x's, okay, if I were to graph it this way. Do you think 27's fitting on that graph? No, it's not. So we're actually not going to use that one, okay? And since we said that cube roots can be negative, we actually need to find the cube root of some negative numbers, okay? So instead of -1, -2, -3, we're just going to do -1 and -2, okay? Because we know that -3 is going to be a -27, and we don't need that, okay? So let's go ahead. We'll start with -2 to the cubed, and then -1 cubed. And what are those? -8 and -1. Okay, so those are going to be the cube roots, the perfect cubes that we want to use for these. And how this is going to work, it's going to work very, very similar to what we did before. However, instead of 0, 1, 4, 9, you now need to know -8, -1, 0, 1, 8. And let me show you what I mean. What's my radicand on the parent function? Just x, okay? So when I go to write my xy table, over here to the left, I'm just writing x equals -8, x equals -1, x equals 0, x equals 1, x equals 8. So since I don't have to solve those are just what they are. -8, -1, 0, 1, 8. Okay, I know that there are two more numbers up there than what we did before, but that's okay. Okay, now I just evaluate. So you have to use a calculator on these. Here's how you're typing this in. So grab that calculator. I want it in your hand right now. You are going to type in 3, okay, because why? This is my root. It's a third root, okay? So type in 3. Now you're going to hit the second button. And now instead of that square root button, you're going one above it. It has a caret on it, but right above it, you see it looks like this. Whoa, hold on. Okay? What you're telling your calculator is you just typed in 3. So you're telling your calculator that this x equals 3. My index is 3. And now I'm hitting this button. It's going to start flashing with a parenthesis and an open box, and now you just type in your x. So for the first one, you just type in -8 and hit enter. And what do you get? -2. Now, hit the back arrow and make that -8 a -1. -1. Now make it a 0. You're going to have to delete the negative out. 0. What about 1? And 8? 2. Good. So now I have 5 points that I'm going to graph. -8, -2 will be right here. -1, -1. 0, 0. 1, 1. And 8, 2. So a cubed root is going to look like this. What's different about that than a square root? Yeah, it's still got a negative part of the curve, right? It's not just like our square roots, they just kind of look like this. Okay, but our cubed root, it has the whole thing. All the way across the graph. Okay, so the turning point, what the turning point means is just where does this curve start to go the other way? 0, 0, okay? Just the middle point of my table. That's my turning point. That's not super important, but you might see it on the EOC. And then my domain. Okay, so think about this. From left to right, so my x-axis, where am I starting and where am I ending? -infinity to infinity. Guess what? Every single cubed root has a domain of -infinity to infinity. Kind of like our absolute values and our quadratics, right? Okay. What about the range? What do you think? Y-axis, bottom to top. Where do you think I'm going? So actually this arrow, even though it doesn't look like it, it actually kind of slants downward. And this one goes up. Yep, -infinity to infinity. Always, always, always on these. Okay, we know that our range was different with the square roots, right? Because it didn't go all the way up and all the way down. But these do. That's going to be the same thing. Domain and range, you can box that, star that, highlight that, whatever you want to do. That's going to be the same on all of these. So there's no reason you should get that wrong. Okay? 2 free points on every quiz. Woohoo! You with me?
So if you want more, can I just turn in domain?
Absolutely not. You got to turn in everything. Really funny thing to say, though.
Okay, good. Is that partial credit then?
No.
There's no partial credit?
I'm just going to draw a big frowny face and just give it back to you.
Turn that frown upside down.
Great. Okay, these work the exact same way. This looks just like a square root function, doesn't it? What's it missing?
The x.
A little 3.
Now let's talk about the x on the end.
Okay.
Where it has
The X on the thing.
x on the calculator.
Okay. Yeah, the index, right? The index. But on a cube root, isn't the index always going to be 3? Yeah. So just go ahead and put that in there. Then we've got h. What is h? Same as before. What's it tell us? Left or right. So h is the left or right shift, or the horizontal shift is what we would call that. If h looks like it's positive, where are we going? Left or right? Left. If h looks like it's negative, right. K is the vertical shift, so up and down. If it's positive, we're going up, and if it's negative, down.
Why is the horizontal like
Say what?
opposite?
Because that's the y-axis.
Yep. It just always is.
Yeah, but if it's a positive, why does it go to the negative side?
Because that's just how it is. Don't overthink it, Timmy. Ending point / turning point on these. These are still going to be your negative HK, okay? So kind of like what our vertex was. Your end point or your turning point, so where these things turn around, is negative HK. And if we look up on our parent function, we didn't have an H, we didn't have a K, that's why it was 0, 0. With me? Okay. If A is negative, the function is reflected across which axis? X, just like before, reflected across x-axis. If A is bigger than 1, so the absolute value of A is bigger than 1, vertical stretch gets bigger, and if it's smaller than 1, shrink or compress. Whatever word you choose to use does not matter to me. Okay. All right, given the following equation, describe all the transformations that would take place. Go ahead and do this now. All right, Alexis told us the first one is what?
Stretch 4, right 1.
Stretch 4, right 1. There's a little bit of confusion on this one. Stretch 4, right 1. If you thought that this whole thing was underneath of the square root, because it kind of looks like it could be, but it might not be, then that would be correct. If you said stretch 4 and then right 1, okay? But to me, it kind of looks like that negative 1 might not be under there. It might be out to the right, okay? What would that be? Down 1, okay? So it'd be stretch 4, down 1. A little bit of confusion on that one, but I think that negative 1 is actually supposed to be not underneath. So it should be down 1.
It's not, because the one below it.
Yeah, then the one below it is under there. You're right.
Oh no, wait, okay.
Okay, Alana, so what'd you put for number 2? Reflect. Good, because it's negative. Left 3. That's it. All right. Question. All right, any other questions on that? All right, let's go ahead, and we are going to start our first graph. Fun stuff. It is fun. These are really not that bad. Okay, so we're going to go ahead. First thing we always do is we draw our t-chart and we set up our equations to the left of it. So we're going to start off here, x and y. We're going to put our equations over to the left. What is my radicand? X plus 3. So I'm setting that equal to 5 different numbers on this. Anybody remember what they are?
0, 1, 0.
Yep, so we'll go in order. Negative 8, negative 1, 0, 1, 8. Yep, negative 8, negative 1, 0, 1, 8. Negative 8, negative 1, 0, 1, 8. Now we just solve these equations, and that's going to tell us what our x values are that we need to plug in. So when we do that, we've got to just subtract 3 over on all of them, right? So what's negative 8 minus 3?
Negative 11.
What's negative 1 minus 3? What is 0 minus 3? What is 1 minus 3?
Negative 2.
And 8 minus 3? 5. Okay. So now, get those calculators handy. I don't want you to have to do this in your head. And don't expect it. You could. You very well could. But we're going to use the calculator, okay? So what you're going to type in, we don't have an A value, correct? So the first thing we type in is just our index. So it's going to be 3. Then you're going to type in second and go hit that caret button so you get the little symbol that looks like this guy. What's my first x value? Negative 11 plus 3. Now here's the kicker on this one. Make sure you shut those parentheses. Why? Yep, otherwise it's going to think that 2's under there with it, and it is not, okay? It's just outside to the right. So you just need to know how to shut those parentheses, and make sure you do that, because if you don't, you're going to get the wrong answer. So on the first one, what did it give you? 0. Okay, now hit the back arrow. Go back. Delete out the negative 11 and put in a negative 4. What does it give you? 1. Okay, now negative 3 is next. 2. Negative 2 is next. 3. And 5 is next. 4. Okay. Anybody not get these? Now we just plot those points. So let's go ahead and do that. Negative 11, 0 is going to be right off my graph a little bit. Sorry about that. Negative 4, 1. Negative 3, 2. Negative 2, 3. And 5, 4. And now we just draw our little curve. Raise your hand if you did not get that curve that I drew. Yours probably looks a little better than mine. Okay, first 2 questions there. Domain and range, what are they? Yep, both of them, right? We're going all the way left to right, all the way up and down. We're down to up. Yep. That one looked a little weird. And make sure, I don't know if I told this class this or not, on quizzes, a lot of us have been writing negative 8 to 8, okay? Make sure that your infinities are a little bit tilted, okay? I get it that it's easy to draw an 8, but make sure you don't actually write negative 8 to 8.
Well, you could just turn the whole paper sideways. And just
Yeah, you could do that. Turn your paper sideways and write an 8. That works. Good strategy, Timmy. Okay.
I just came up with it though.
Okay, yeah, that's fine. All right, let's go ahead and we'll do increasing, decreasing next because those are pretty easy. So looking at this graph, I've got Catherine. Here she is. Everybody say hi, Catherine.
Hi, Catherine.
Okay, she's running from left to right because that's how intervals work. From left to right, she's running. She going uphill or downhill? And we said this arrow's going up forever, right? Is she ever going down? No. So the increasing interval is what?
You gotta run uphill
From left to right. Yep, Catherine's running uphill forever. Negative infinity to infinity. That's her increasing interval. Is she ever running downhill? No. Make sure you write in the word none. If you leave it blank, I'm going to think you didn't know.
Well, it's technically none. Like, you didn't write none.
But I need you to write none. Okay. X-intercept. Does this touch my x-axis?
Yes.
At negative 11, 0, right? Yep. What about my y-axis?
Yes.
Yes, but does it look like it's a clear point? Is it a point that we have in our table? No. So here's what you've got to do. You have to plug in 0 for x to find the y-intercept. So you might want to write that. Plug in 0 for x. So if I go up to my equation, I'm just going to change f of x to y just because it's the same thing. Y equals cubed root of 0 plus 3 plus 2. Hopefully you kept your calculator handy and you don't have to go retype in the whole thing. But if you do, it's fine. Go put in a 0 for x. And what do you get? 3.442. So hold on. When x is 0, y is 3 point, we'll just call it 3.4. And if I look at this graph, does it look like that's about 3.4? Yeah, I think so.
Oh, it looks like 3.5.
Okay, that's fine. So as long as it's a good estimate, okay? Does that make sense? One other thing too. And you might want to write this next to the x-intercept. Sometimes our table won't always give us the x-intercept. How do you think we'd find that?
Look at the x-axis.
Mathematically. Plug in what? Yep, plug in 0 for y to find the x-intercept. Okay. Next up, limits. Save the best for last. Yay. You want me to make a song? I don't think you want that.
Like a math song.
A math song? I could probably find a math song online, but I'm not going to make one. I'm not going to make one.
Can I make one? Can we
Sure,
use it?
I would love for you to make
Can we use
one.
it in class?
Oh, every single day.
You would?
Yeah.
Give me a subject. I'll make a math song.
Oh, make a song about this.
What is it called?
Are you serious? How do we start limits? The first two parts are easy. Easy, easy, easy. What is it? What do I put for the approaching? To what? Yep. That's going to be the same for all cubed roots, okay? We know it's our domain, our left bound to our right bound. And if you need to put L and R here just so you're clear, do that. Left to right is our domain, so our first limit is our left bound, and our second limit is going to be our right bound for this. Okay? So, here's what we got. First one is our left bound, correct? So, let's think of a bird. It is flying to the left. Flying to the left. So, coming in this way. The bird is flying. Do you see how it's flying to the left? It is, it's a bird. It doesn't go straight. It's very windy. So, it's flying to the left. As we're approaching our left bound, which is negative infinity, where's y going?
Down.
Down. To where? Yep. Okay, so the bird's flying into the right. Alana gave it to us already. As we're coming into the right, towards our right bound, which is infinity, what is y doing? Going up forever to infinity.
I remember when I used to run cross country, it was muddy.
Yep. So Timmy said when he ran cross country, it felt like uphill forever. So think about Timmy when you think about cube roots. Okay.
And when I make the
When you make your song. Okay. We'll be expecting it. All right, example 2. Example 2. All right, let's go ahead. This is the last one we're going to do together, and then the next two, you're going to work with people. Woohoo. Okay. Yeah, people in here. Okay. First thing we always do, always, is we draw our table. That's not a very good table. I'm going to do a better one. I don't know if that was better, but... What is my radicand? Just the x plus 1. Do we all see that? That is the only thing underneath that cube root. So I'm going to set it equal to what?
so is that going to be the same as the
Uh-huh. Yep. And on the square roots, what were the 4 numbers? 0, 1, 4, 9. These are always going to be -8, -1, 0, 1, 8. Makes it easy.
You said that too fast for my brain to process that.
Okay. You got time, Timmy. So now, how do I solve these equations? By doing what operation? Subtract 1 over each time. -8 minus 1 is? -1 minus 1? 0 minus 1. 1 minus 1? 8 minus 1. Cool. You got your 4 numbers. Get out that calculator. Okay, this one is a little bit different, and I really need you to pay attention to this. Okay?
You have to do the 1/2 then 3 thing.
The 1/2, then 3. So the reason for that is if you just type in 1/2 and then you hit in 3 for your index, it's going to read that as 1/23 for your index. And that's not going to work. Okay? So what do you think would fix that? Parentheses. Okay? So we're going to have another set of parentheses here. So you're going to type 1 ABC2, so it reads that as your fraction. Now you're going to hit parentheses. Type in your 3 so it knows that's your index. Then you're going to get this little guy. Then it's going to open up the set of parentheses that it always does. You with me? Okay. We're still going to type in a -9. We're still going to type in a -9, okay, because that's our x, plus 1, because that's also underneath the root, correct? Shut those parentheses, and now shut them again, because is that 1/2 being multiplied by that -5? No, it's just being multiplied by that radical. So then type in -5.
Oh, I didn't close up parentheses.
Okay? So basically this set of parentheses I'm drawing in red, that's just what's underneath the radical. Okay? But you gotta close it again. You see what I mean? Because that whole thing is being multiplied by that 1/2. We're distributing.
I got 5.
Did you do the -5 at the end?
Yeah.
Okay, hold on. So what did you guys get? Yeah, it should be -6. Okay, so just hit that back arrow now. And go and change this -9 to what? -2, because that's our next number. And then hit enter.
I got -5.
-5.5? We all agree? Okay. We'll keep it as a decimal. Now -1. -5. 0. -4.5. Positive 4.5. And 7. What do you get when you type in 7? So make sure you delete out the negative.
-4.
What'd you say?
I got -4.
-4? So the negative, this was supposed to be negative? I think that was right. Okay. So make sure you're typing those in correctly. And most of the time, Alexis, when you realize, okay, this goes from -4 and then you thought it went to positive 4.5 and back to -4, that probably tells you to go recheck that, okay? Because you know that's not going to look right.
I got negative for both of those.
Yeah, okay. Cool. So now we just plot those points, -9, -6, -2, -5.5, -1, -5, 0, -4.5, 7, -4. And now we draw our little curve. This one's doesn't look so curvy, does it? Why do we think this one doesn't have such a defined curve as the others?
Because all of the y's are negative.
What about this 1/2 out front? Is that a stretch or a shrink?
Sure.
Shrink. Does this shrink? Yeah, it shrinks closer to our straight line, okay? So that's why it looks so funky. Domain and range, what are they? -infinity to infinity. Range is -infinity to infinity. Increasing. We got Lucas. Everybody say hi, Lucas. Hi, Lucas. He's running. His hill's not quite as steep, right? But is he going uphill or downhill? The whole way? Yeah. -infinity to infinity. Do you see your hair, Lucas? It's good. I should be an art teacher. Is Lucas, is he ever decreasing?
No.
No. None.
Yeah, no one frame on this calculator.
Does this give me an x or a y intercept? Gives me the y but not the x. What's the y? 0, negative 4.5. And that was actually one of my table ones. So anytime one of your x's or one of your y's is 0 in your table, that means it automatically gives you an intercept. Okay, you just got to go see which one. And this, I can tell this crosses my y-intercept at that point. Or my y-axis, I mean. X-intercept, do we see this crossing the x-axis on our graph? No, we don't. So we've got to do what? Plug in what? Plug in 0 for y, because we don't know what it is. So when I do that, 0 equals 1/2 cubed root of x plus 1 minus 5. Now I'm going to go down here and solve this. First thing I've got to do when solving these equations, add this 5 over. So 5 equals 1/2 cubed root of x plus 1. Is the root isolated? No, so what do I need to do?
Subtract the 1/2.
Is it being added right now? Divide by 1/2 and type that into your calculator, and what is it? 5 divided by 1 ABC2. 10. Now how do I get rid of that radical? Cube it. 10 to the third power is what?
30.
Not 30. 1000 equals x plus 1. Subtract 1, and what's 1000 minus 1? Wow, that's a big x-intercept, right? And that was never going to fit on our graph, so that's why we had to find it mathematically. So it's 999, 0. With me on that one. Okay, last but not least, limits. What are my approaches?
Oh, that's left and right. The top one goes left.
Hold on, so what x approaches what on the first one? Negative infinity, because that's my left domain. And then x approaches infinity, that's my right domain. The bird is flying in from the left. As x approaches negative infinity, what does y do? Negative infinity. It equals negative infinity. Okay, so then as the bird flies in from the right, Alana told us it's going up forever. So positive infinity. That not very neat. Okay. Questions on that? When is lunch? That's not a mathematical question. Number 3, it looked like some of you guys had this one, or had a pretty good start at least. We've got our XY table, because that's how we start these problems. Don't ever tell me you don't know how to start it, because you got to start it with a table. And then, what's my radicand? Setting it equal to what 5 numbers?
-8, -1, 0, 1, 8.
Good. When you solve, add 2 over. What's the first x? Then? 10. Okay, now go to your calculator. Type into parentheses 3 root of x, which is going to be -6, minus 2, close the parentheses, and then add 1. -3. Next one. Next one. Then 5. Plot those points. -6, -3, 1, -1, 2, 1, 3, 3, and 10, 5. So now when we draw that line, it should look like this. Raise your hand if you got that one so far. Sweet. You should be graphing pros by now. Domain. Negative infinity to infinity. Good. That is the domain on all cubed roots. Range. Good. That is the range on all cubed roots. Limit. Okay, so let's start with the approaches. On the first one, it's going to be negative infinity. The next one, again, we just always rewrite our domain. So always, always, always just rewrite the domain for those. For the left bound, when the bird flies in, as it approaches negative infinity, where's it going? Where's y going? Yep. And the right bound. Increasing. Good, it's always increasing. Is it ever decreasing? X-intercept. How'd you get that? Plug in 0 for y for the first one. So when we do that, 0, start up here, 0 equals 2 cubed root of x minus 2 plus 1. Subtract the 1 over first and then divide by 2. So you end up with negative 1/2 equals cubed root of x minus 2. You with me so far? Then we cube both sides. Negative 1/2 cubed. 0.125. That's fine to leave it as a decimal. Equals x minus 2. Add the 2 over and you get 1 point what? 875. So when x is 1.875 or 1.9, y is 0. Now we just have to do the opposite to find the y-intercept, right? Plug in 0 for x. So when I do that, y is going to equal 2 cubed root of 0 plus 2, or sorry, minus 2. Minus 2. And then plus 1 on the end. And what's that going to be? Negative 1.5. So 0, comma, negative 1.5. Which it looks like that's about where it is. Cool. Questions on that? Feel good about that? Okay. Number 4, we said we were changing. We were going to switch this to a negative x to the 1/3 plus 4, just because I want you to see what the negative ones look like. Have we done a negative one yet? Nope, not yet. Okay, it's going to look a little different, just like our square roots did. Not just like it, but different. Okay, start with the table. Radicand on this one. Well, if I rewrite this problem, isn't this just the same thing as this? Is that 4 going to be underneath of the root? No, because it's not being taken to the 1/3 power, so it's not part of the radicand. So my radicand is just what? X. So x equals negative 8, negative 1, 0, 1, and 8. You with me? Because I didn't have to solve anything. Okay. Now, these ones are really easy to go type into your calculator. You can even just type it in the original way. So negative, you'll want to use a parenthesis on these. That is important. Type in negative 8 to the 1/3 power. Add 4. What you got? 6. What about negative 1? Just hit the back arrow. 0. 1. And 2. Okay. Plot those points. -8, up 6. Whoops. -1, 5. 0, 4. 1, 3. 8, 2. With me so far? Okay. Domain on this one. -infinity to infinity. Good. Range. Same thing. All right. Let's start with our intervals. Am I increasing on this one? Be careful. No. Why?
Because it's going down.
Going down. So we're going to write none on increasing interval. What about the decreasing interval? Yep, it's always decreasing. X-intercept. Plug it in. Yep, this one's not obvious. Plug in what? 0 for y, so 0 equals -x to the 1/3 plus 4. Subtract the 4 over, then divide by -1, right? So x to the 1/3 equals 4. Now what? So take it to the 3rd power. What's 4 to the 3rd power? 64. Yep. So my x-intercept is going to be 64, 0. What about the y-intercept? 0, 4. It gave it to us already. It's in my table. Limit, left bound limit, matches the domain as it approaches. Right bound limit matches the domain as it approaches infinity. Okay, so bird is flying in to the left, approaching -infinity on my x-axis. What's y doing? It's going up. So y equals infinity as the bird flies in from the other side. Bird's flying in and y is going down. So it's -infinity. You with me on that? See those flip-flopped. Why do you think those flip-flopped from the other problems that we did?
Because it started with a negative.
Because it started with that negative. A was negative, so it's gonna be reflected. You with me on that? Seeing how these line up, how they make sense? We got time for just these last two. We got about 5 minutes. Writing equations from a description. A cube root function translated 5 up and left 7. Let's write it together. I'm just going to write what we know. This is the same for everything. So it's a cube root. If it's going 5 up, where am I putting that 5?
-5.
Mm.
No, it's gonna be after the next number.
Out here?
That's
And then left 7. Plus 7 underneath. Good. Anything out front? Nope. Next one. Stretch vertically by a factor of 3. Reflected over x-axis. Shifted right 3. -3. Good. All right. How are we feeling on that? Not bad? Sweet.